Hi, good morning. Very pleased to be here today. My name is Eyal Shani. I'm a Director Technical Product Marketing located in corporate headquarters in California. And today I'm going to talk to you about the devices part and how we see the future of data center. So when we're looking at the data center in front of us, we see three key trends. So scale, more important than ever, more applications, more services, more infrastructure coming online. And therefore, it's not a surprise to see that 37% of total IT infrastructure spend is on storage, and growing, by the way. Then, as we're looking at the second trend, which is hybrid. So for a long time, there were all kinds of statements out there. Cloud is going to win. On-premise is going to do something else. And this kind of statement that 90% of organizations are actually see value in a hybrid solution where some of the applications are going to continue and run on-premise and others are going to migrate or already migrated to the cloud. For us, it's a sound of a maturity which was needed, and I guess it talks to the maturity of the market out there. And then third, and maybe the most disruptive to us and to the industry, is the customization, the specification. The one size definitely does not fit all. Okay? So it's becoming, where Esther mentioned the big data versus the fast data. I'm going to also mention the distinct application. Whatever works and optimizes for AI is not going to be the right architecture and the right care abouts for the ML side. Although everybody is saying AI ML, two distinct requirements which require different architecture, building blocks, optimization, core structure, you name it. So we're spending a lot of our time, and I feel that the industry as a whole is doing a lot of that, to get it specific. And that's going to take time, and we are all psyched and excited about this trend coming. So yes, the growth continues, and it's a healthy one. We feel that we are in a unique position because we have both HDD expertise, SSD expertise, a fab. We feel that we are in a unique position to collaborate with the industry, to collaborate with our customers, and to get to where we need to be the right fit for customers' base.
Why do you think Western Digital can do this? Because very, very few companies have been able to vertically integrate up from making media to successfully selling systems.
You're asking about I'm speaking to the devices side, but clearly we're doing it already in the DCS side, right? On the system side as well. Are you asking about the devices side or about the system side?
I'll ask Esther later.
Okay. On the devices side, we have been doing it successfully for a long time. We dominate more than 50% of the HDD market. We are climbing to be a substantial player in the SSD market. Going up the stack, making the perfect systems and get to a substantial market share will take time. It doesn't happen overnight. But we have all the building blocks, we have the expertise, and I think we're doing pretty well already on the system, and we'll continue to do that. And again, relevant more on the system side. So the high-level trends can be covered in the last slide, but if we want to double-click on some of the more emerging trends that we see, I think that this slide is going to help us do that. So taking a look at one of the more disruptive customers out there, maybe even bleeding edge, I think it's going to help me to substantiate that. So this specific customer, through their app and infrastructure, already today support millions of users and billions of trips. Their application suite generates huge amount of data every second, every minute of the day across the board. They are already at scale, they are already generating a lot of data, The interesting thing is that if just a few good years ago, the majority of this data was very much unusable, numbers talk to less than 1% useful data. This is now changing fast, and the new numbers refer to closer to 10% of all this generated data being used, leveraged for various internal means. So data is very much in the middle. A second trend that we see is that if in the past this data that was generated was strictly used by the application that was using that generated it, kind of a silo use, this is slowly changing in a sense that you're starting to see applications share this data around between them, kind of a data exchange mechanism, which is very interesting. It's not going to happen overnight, but it's starting to happen already. And since this data is not siloed and protected anymore, and maybe you can talk to a mobility of data, that brings up all kinds of challenges when it comes to privacy. So all kinds of new innovations are starting to be utilized in order to be able to protect and to guarantee the privacy of this data, or should we say of our data. So this is a very good disruptive customer for us to work closely with. It's not like they're sharing their secret sauce with us, but they are sharing their unique problems on I/O and storage with us. And these are the kind of customers that get us innovative and get us to bring better and better products across the board. We're talking HDDs, we're talking SSDs, and emerging technologies as well. So clearly the market appreciates choice when we talk about technology for sure, but also when it talks about price points. And this slide for Gartner, actually this is a take on the IDC slide, my mistake, is helping me illustrate a few points. So the first one is that 50K HDDs have been already taken out by basically not having a relevant and attractive price point. 10K is still there, and it will take a bit longer for it to disappear. On the device level, on the dollar per gigabyte, it still shows some benefits over SSDs, but as you go to a solution level, as you go to the rack level, a lot of this mass HK SSD using for origin servers and such have been already taken out by using much smaller number of SSDs with a very much attractive read IOPS capability. The next bullet I want to mention is the NVMe versus the SATA SSD price points per swim lane. So, like everything new, NVMe had a premium for a while, but what we see now is that this premium is disappearing, and going forward, at least in the next few years, NVMe and SSD are going to have a kind of consolidated price point. If you're scratching your head and asking, what did he just say about for the next few years? So actually what's going to happen is that as NVMe enters the mass shipment and economy scales, this premium disappeared. The interesting that will happen soon is that SATA, which is definitely becoming niche, is going to order some premium on that front just before it disappears completely. Like any niche.
What justifies the premium on NVMe at the moment?
So that's what I'm saying.
It's all solid state, isn't it?
Well, so look at the investment. I was visiting a customer, which will remain nameless, just last week, and we were talking about all these innovations that are coming. And I'm telling him, well, you know, we're going to have this, specifically talking about form factor coming up soon. And he's saying, oh my God, this is going to be such a joyride coming, because each time you change something and you introduce a technology, that creates a lot of extra effort for the industry. Even if you have the devices, you need to test it, you need to validate it, you need to change your validation maps.
Which is why SATA will carry a premium, because there'll be some people that don't want to do that.
The premium that will happen with SATA, it's because it's not shipping 90% of compute anymore. It's not shipping 90%. NVMe is going to be that. Okay, so suddenly when as us as a company come to try and look at what we're going to focus on and how many swim lanes and how many investment we're going to do, we need to phase something out in order to introduce something in, right? It's a zero sum in the end, right? So that's a pure economy statement rather than anything technology-wise.
Basically, there should be no relation between the price and the material cost.
Oh yeah. I'm just wondering if you take a 256 gigabyte PCIe SSD and a 256 gigabyte NVMe SSD.
Yeah. If you look at the specifics, specific point in time, I see your point. But think the following: 3 years ago we had 3 swim lanes in SATA. Today we have a single one. Okay, what?
Explain what a swim lane is.
Swim lane means we have 3 product lines.
Yeah. Yeah.
Okay, so which means, and every time we have a new NAND node available, we're going to do everything we can is to optimize time to market.
Yeah.
That's not the case anymore with SATA because it's basically deprioritized. So when we need to come and facilitate our resources, our focus, our innovations, it's going to be on NVMe. It's not going to be on SATA. In 2 years, you will be only able to buy a SATA SSD, which is based on a 2 years old
So
NAND.
what I'm getting at, and what
Yeah.
I think what you're saying,
I need
is
some water.
really the only difference is down to which one's in bulk production and which one's a minority.
Economy
product.
of scale, yeah.
The actual piece that fits in my laptop.
Well,
Yes,
there is
we
a-
are aligned.
Let me add just one comment to that.
Thank you.
Okay.
I mean, when you're looking at an SSD, if you're looking at a consumer SSD, vanilla is vanilla is vanilla. Okay, I mean there is not, you can't make it into a chocolate. But if you're looking at an enterprise class SSD, there are differences, right? If you look at NVMe, for example, we currently have 3 different products, if you will, categories. We have a very read-intensive product category that's meant for, that doesn't have a very powerful controller. We have kind of a mainstream NVMe SSD, and then we have a high-end that has dual port. So the controllers inside of these, the amount of RAM
Yeah.
inside of that, the power fill circuitry in that's hardware that has a cost associated with that. So there will be premiums depending on the kind of, if you have entry-level, mid-range, or high-level. And so with SATA in the enterprise, we typically had 1, maybe 2 kind of flavors, but the NVMe, even the same level of NVMe that is replacing SATA now, still has quite a lot of premium in terms of its capability, and and because of that, there is a slight premium in price. Eventually, the economies of scale will make that
So
disappear.
you justify it on the complexity, added complexity of the controller, and
There is
possibly
different kind of RAMs in there, and
Yeah.
yeah. It's not only the flash. The flash is a big part of the BOM cost, but it's not only that.
In reality, we are exiting this period, right? And again, I need to be careful. This is not a single line for NVMe SSDs as a whole, because I just told you, it's all about customization. This is an average of all the different product lines. So in average, right? But as I will illustrate in a few slides, there's actually more and more different architecture at different price point on NVMe that are coming, okay? So this is a fine point that needs to be, and I think that by the end of my section, if you have still questions about that, we can definitely talk about that.
Do you
Is
still?
SAS an orphan?
Sorry?
Is SAS an orphan in your space?
Again, in a couple of slides, I'm going to talk about SAS. SAS is still here. It's not going to disappear overnight because nothing does. But if you look at overall new designs that are happening now, most of the effort is in NVMe, especially when it comes to SSDs. And I will explain more in a few slides.
Do you still believe that 15K, the price will be stable?
So the 15K price is as stable as something that doesn't exist anymore. which is the stablest thing alive, or not so alive, I guess. Okay, so the 15K
You're
one
dead,
is
you're dead.
done. It's a bit more a fine statement when you're talking about the 10K. It's not a secret that we have discontinued 10K. Because when we looked at the mass market, and by the way, we have SSDs, and very attractive one to take over that was the right choice for us. Okay? There are still some vendors that decided to leave that for maybe a good question to ask them, but the majority of the market opportunity is not there anymore. The only opportunity that you have with 10K HDDs anymore is this 4 or 5 HDDs in a RAID for very specific usage. This is not enough to leave a product line alive.
So that's the price you'll be paying on eBay for them, if you really need them.
I'm not an eBay person. I spend my time dealing with the cloud and OEM, but again, clearly 10K has it's done marvelously for us for a company, but we have a choice and we decided to put more
But there
investment.
will still be people who need them because that's what's specified with their box and they can't update it.
So yes, eBay is a good way to look at that maybe.
Yeah.
It's like antique
How
cars.
Okay,
The older they get,
so-
the price goes up.
Yep.
much
So when
Did you see
I
them
was
now
told
get
that we
electric drive trade for Jaguar E-Type?
So I should have understood that when I heard that there are a lot of analysts in the room, that this slide is going to get very attractive. So, but maybe during lunch we can continue to talk deeper about this slide. There is only actually one more statement that I want to mention here, and this is this swim lane here, which is the capacity enterprise HDD. So maybe the number one statement in this slide is, look at the gap here. Look how healthy and substantial it is between SSDs. Let's leave the protocol question aside. SSDs and capacity enterprise. And the one thing to take from that very clear visual is that capacity enterprise is not going anywhere. It's not going to disappear. And actually, according to our data points, very reliable ones, this is actually going to be a very important growth engine for enterprises, specifically for cloud. And if you have some other voices out there talking about QLC replacing HDDs, then let's add a very specific statement there. They are talking about replacing 10K and 15K HDDs. They are nowhere close to replace the enterprise capacity point.
If that's a straight line graph, at what stage will the hard drives be free?
Ooh. Never if we can help it. Okay.
When we retire, how about that?
So let's talk a bit about what we see in enterprise and how it's going to continue and be a key driver. So as I just mentioned, capacity HDDs innovation enabled the growth in cloud storage. And what we see here on the left on the graph, we see that actually this capacity enterprise HDD, which is here as core, because it's really becoming our core business when it comes to HDDs in the data center, is going to grow to be more than 50% than overall HDD shipments, exabytes, and all. So when we're talking about HDD innovations, we were the first to ship 12 terabyte helium drives back in 2017, facilitated by our 8-disk capacity, 8-disk, which was the news then. Then in 2018, just last year, we were the first to ship the 15 terabyte SMR. Okay, and going forward, during 2019, we already right now sampling and in a quals slots with key customers with our 16 terabyte energy assisted drives. And towards 20, we're going to ship 20 and 20 plus capacity drives, again, emphasizing the ability to do that through energy assist capabilities, as well as new innovations like dual actuator. And there was a question before which I answered yes to, which is always a good thing to do. But when you said multi-actuator, you meant dual actuator? Okay, good. So I got it right. And very important statement in this slide is that we are on track. All technologies that we rely on to continue this specific projection on technology and growing terabytes shipments on capacity enterprise.
Will you stay with Mama and not use Hammer?
That seems to be the case, yeah. That's what we believe in. So we spent 2 minutes now talking about all the good stuff that we're shipping, but there are definitely a lot to talk about the technologies underlying and allowing us to do this leadership on HDDs. So we already launched, and I just mentioned the SMR, the single magnetic recording drive, which is allowing us basically to increase areal density. So for example, we took our 12 terabyte drives, which are CMR, conventional recording, and by using our SMR technology, we were able to move them to 14 terabyte. Okay? So from 12 to 14, this is 16%. What we were able to do then is to push a bit harder and take this 14 SMR and ship a 15 SMR, which is what we did late last year. And that's already a 25% more areal density. So this is how you see SMR enabling, especially cloud, to ship higher density and to be more effective when it comes to density per slot. Then on the media optimization, we moved from 95 to 97 millimeter, and we used larger disk number, so we moved from 7 to 8. So it's more media, more disk, and more disks. 7 going to 8, and that will surely go beyond 8 when the time is right. And then if we come to look at the superior mechanical design, we are now talking about micro actuator as opposed to multi-actuators, right? So just to explain, if long time ago, actuator, which is helping us to do this fine control on the track, it's a mechanical capability, you had one kind of actuator. But as the technology progresses, and you need to use to enable more and more finer capabilities, we introduced, first of all, this dual actuator, the dual stage actuator. Now we are adding the micro actuator, and there is a lot of innovation even in this head in the side, which is yet again the last point here, which is the Damascene process. So a lot of mechanical optimizations, years of very intimate innovation cycle, lots of new innovations coming that will be required to continue and drive capacity higher. Okay?
Will the 20 plus terabyte Mama drives in 2020 be shingled media recording or normal recording?
It will be mainly supported by the shingle capability. Yeah.
You bastard.
Okay, so helium already, it's an established technology, but just a few years ago it was the real buzz. Look how many drives we were able to ship. 40 million plus drives shipped on helium. That's amazing. And the key last point I want to make it, we're going to continue and need to innovate on recording, on media, on head and reader, and mechanical design, because you can't continue and raise the bar without leaving a bottleneck on each of those. By the way, I just noticed that I forgot to talk about the Damascene process and the head, so let me do that very quickly. So the last point on the head is the following. We have invested hundreds of millions of dollars, close to $300 million invested in the Damascene process, again, to allow us to have the right head technology that in time allows us to go and do finer and more specific linear capability on the read and write on the drive. This Damascene process is what allows us to now take it and go through this energy-assisted, as you mentioned, MAMR projection. MEMR is an umbrella name for everything, which is basically means we need to apply some extra external energy to be able to complete the recording capability.
But that includes hammer in that definition.
So hammer is heat assisted, whereas MAMR is officially called microwave assisted, but definitely it's energy assisted. Okay?
And heat is energy, so what's the difference?
Different branding, I guess, but also different pain points. As you need to not just make it work in a lab, you also need to make it work in a mass production.
Oh,
in very good yields.
You haven't made MAMR work in mass production yet. Seagate would be laughing in your derision.
So I don't want to talk about Seagate, but the Damascene process is already a process that is shipping, right? So I think that 2019 is year of the pig, right? If you ask our Chinese friends. But we want to add some value and call it year of the SMR, right? Because 2019 is going to be the year where you're trying to see, or you're starting to see, actual and substantial SMR shipments in the market. And the way we're going to ship SMR in 19 is through working the last 2 years at customer sites with them to make the technology work, to adapt their software stack, because this SMR is the host-assisted SMR, the kind that actually bring more value. And that requires customers to go into their software stack and do some changes on optimizations. So after 2019, where you're going to have the key cloud guys and scale-out accounts ship SMR, you're going to see a very fast adoption of that. Oh dear, I see I'm behind. So just to mention here, one of our customers talking how great SMR is working for them. This is Dropbox. Clearly, more storage for them is key. Yeah. So back to the questions about multi-actuator, dual actuator. So basically, for the majority of customers, capacity enterprise is about capacity. But for a handful of customers that still want to use this technology for IOPS sensitive applications, we came with this innovation where you're adding a second, hence dual or multi actuator. That's not the micro actuator, it's actually another full actuator, as can be seen here, first and second. The way you use it forward is that the first actuator is in charge of the higher 4 disks, and the second actuator is in charge of the lower 4 disks. And this is how you go back into linearity of read IOPS. And by the way, we're talking about read IOPS, which is more of an issue. We solved the write IOPS for just doing more write caching on the media. So this is not shipping yet. We have demoed it early this year. We're going to demo it again in OCP middle of March. And that's not for 100% of the customers, because a lot of them just don't care. But for the ones that were limited in this way, now we are going to have a solution for them as well.
When do you go GA with it?
Stay tuned. There's going to be
Pricing
a statement about availability
and price?
and price. Of course, it will need to come together. So just to wrap up the HDD portion, and I'm a bit behind, so I need to go faster here. We have already mentioned. This is too fast already?
You speak too fast.
Okay, we have a full lunch to do, but let's respect our DCS friends here. So I'll need to accelerate a bit. We already stated that we see a clear path to 40 terabyte HDDs, which is amazing.
Shingle.
Again, at every single point in time, the shingle is going to give you 16-25% better. And by the way, as you go higher in capacities, you're going to get more. Okay? So, and this is going to be available through this free, clear innovation. The energy-assisted recording, which is a must-have, the mechanical improvements, and the media innovations.
Do you believe all statements by vendors about future energy-assisted drives, all vendors, will imply or need shingling to get there?
I am not in a position to talk about all vendors.
In your view, generally, is it possible? I mean, you must be thinking that shingling is a bloody nuisance because the shingle drive isn't a drop-in replacement for a normal drive. So you wouldn't have to do it unless you absolutely had to. And if Western Digital is having to do this,
I want to answer it in the following way. For a very strategic customer base for us, aka cloud, if you come to them at every given point in time and come and say, you have the very established technology now, 14 terabyte. If you're using the SMR capabilities, which by the way you worked the last 2 years to enable, you're going to get another 16 to 25%. It's a no-brainer. Now, I'm not saying it's for everybody. Clearly, SMR with the OST side of it is not going to be adopted across the board. Okay, a lot of smaller customers, which are still important for us, are going to feel very comfortable with just the CMR kind of capability. Okay, but they already know that it's not for them to go after this best capacity at a specific time. Okay.
But Chris, just to answer, like not every product from now onwards is going to be
No.
SMR.
no, it's just that we see these hero numbers, and we kind of assumed, this idiot's kind of assumed until now, this has been conventional, not shingle.
So if we're going forward up to the 40 terabyte, from now between now and 40 terabyte, typically, when we're coming out with that higher capacity initially, it may be
So
SMR.
we might see a 40 terabyte shingle drive with a 30 terabyte non-shingle
PMR.
drive.
That's
Something
right.
like that, yeah.
That's right. So it's
Yeah.
kind of like, the 96 layer or versus the 64 layer NAND. It's got to mature a while
Pity
before.
that QLC flash doesn't need shingling.
But you understand, it takes time before we mature these things. So
Yeah.
the higher capacity, will be initially SMR and then it will go to CMR.
3D
that
is
answer
the
your
NAND
question?
equivalent, isn't it? Stuck it up.
Oh, I love these animations. Okay, so we are moving gears and talking about SSDs now. And there was a question before about the protocols in NVMe. So close your eyes and think about how well adopted ATA, SATA, SAS as a protocol is for NAND. It's not. This is the beauty and the clear importance of NVMe. There are now more than 50 innovations being standardized just for NAND, just for NVMe. And de facto, there isn't any additional effort being done inside SATA and SAS for this building block, which is NAND. Which shouldn't surprise us. This is exactly why the industry needed NAND, and everybody is super busy. So the innovation goes where it should. What it actually means is that if you are a vendor, an OEM, a force in the market, and you're making a new project now, and you're using NAND building block, NVMe is the way to do it. Okay? SATA and SAS, with good benefits that they had definitely in HDD, continue to. In SSDs, will not disappear overnight because every project lives for 3 years, 5 years, and then whatever RMA and stuff. But de facto, all new applications in storage architecture being done now are going to be NVMe going forward. Good. So we're going to take the 5 minutes of the questions, and then we're going to land well. I hope. In the army, we were told that we can eat in 5 minutes, so we will. No, we're not going to use that. Too important. So, we talked about purpose build, we talked about customization, we talked about one size does not fit all, and this is exactly what we're trying to show here. If everything is now pouring into NVMe, So clearly, and the specification effort is being done, you need to see more roadmaps and more products being done in NVMe, which is exactly the case. If a couple of years ago, you had 2 swim lanes here in the middle, you had mainstream storage and you had caching compute, now you see it getting pushed to the sides. So I'm going to focus on 3 key new products that we either launched this week or we did a couple of months ago. So if we are starting from what you could call vanilla today in NVMe over here, we are first of all introducing a very read-intensive storage. Some of it call it QLC, but QLC is really a mean to an end, pushing SSD to cost. And that's what we are doing already, and we'll talk about that a bit. Then, if you're going to the right, it's also a cost optimization, but actually the cost optimization and the price cannibalization is on memory. Our accelerator path with the new product family and the segment that we launched back in November, ME200 extended memory drive, is actually doing or enabling to take a DRAM footprint and make it much larger, 8x to be exact. And it's based on NAND. So when you're taking the memory and you're now using a NAND technology to extend it, clearly that's a cost reduction as well as enabling you to do more. And we'll talk a few minutes about that as well. So purpose-built, it's basically impossible to do if you rely on external blocks. You can't deliver that. So everybody already talks about the vertical integration and such. Again, going back to this very key customer I met a few weeks ago, he said, listen, we really rely on your capability to be agile, to be flexible. Because if you know one thing about hyperscale is whatever was true 2 weeks ago is not exactly going to be the case in 2 weeks from now. It means that if we were focused on this capacity, we're going to now tell you different. If we were focused on that specific form factor and we told you no about the others, that might change as well. The only way for us to do that and to be able to get to actual design and revenue is if we rely solely about our controller, our firmware, our validation, our everything. And this is what we see here. And these 2 products that we launched 2 days ago are both fully vertically integrated. The read-intensive product here and the very read-intensive product here, both focused on vertical integrated products. I'll give you 30 seconds to look at the feeds and speeds because they are devices and you care about that. But I will narrate the following. First of all, 3D. So the new SN720 very read-intensive product line is based on 3D. This swim lane is about just enough endurance, so you see it in 0.1 drive write per day. We're highlighting this reliability features here, although they are table stakes in data center, because our competition today cannot achieve that kind of reliability in their products. And our call to fame so far in the media is the IOPS per watt. Power efficiency. Think about it. We're getting close to 400K IOPS, read IOPS, in a mere 5.5 watts. That's what happens when you're doing all the right choices and you design internally. And last but not least, remote diagnostic tool. Basically what it means is that if this drive goes into a data center, even if there are some headaches or health issues, you can't really get that drive physically. You need to enhance and do debug remotely. And this is, again, something that we think we have and the competition doesn't. So feel free to talk about that. Application. We have the benefit that this product was actually available for a few months. And we were definitely talking and working with customer on that. 2 key applications that we see relevant here is the video caching. So think your whatever you're watching tonight on your iPad, you have a last mile caching server, okay? And this is the kind of products you're going to see there, very much used that way. And then a buzzy application that we have is cloud gaming, which is more of the same. It is video with much more latency sensitive scenarios. The second product that we are launching is the read intensive. So we talked about the newest, very read intensive, and now we're going back to the more mainstream storage capability. Again, 3D based, up to 8 terabyte, almost 400K IOPS read, and power efficiency that we can achieve given we're doing everything tightly integrated together. Again, nothing here should be a surprise because this is a repeat of the more mature application in the market, but just to tie on a couple of points here, virtualization is a big opportunity out there, and very often the storage pools inside this application are very, or I shouldn't say very, they are read intensive, and therefore this product is the right fit there. When we looked at object storage, we think that the ability to use higher endurance read intensive drive for journaling, that's a good fit. And if you want to use the lower endurance and get more capacity, that would be a good way to use for replication of storage nodes. And then, last but not least, caching. Although you have much more capabilities, more capable 1 million IOPS SSDs out there, for a lot of the customer and application, 400K is amazing. Only 2-3 years ago, we did okay with 100. So right now, they can take 4 SATA SSDs and put one NVMe drive instead. So that's very attractive. Now, I was told never show a video, which is why we're going to show a video. So let's see how that works.
Digital business across all industries is driving insatiable demand for in-memory computing. The need for data processing speed, scale, and real-time insights never ceases in the competitive digital business landscape. In-memory databases, event streaming, real-time analytics, caching, and other time-sensitive workloads drive demand for scalable memory-centric infrastructure, notably expensive DRAM. But how much DRAM is enough? Your business can't afford the slightest drop in performance when digital business executes in the blink of an eye. Sometimes, what you need isn't an answer, it's a new way to approach the question. What if there were a way to accommodate the growing volume of real-time application data using fewer nodes, less complexity, and at a reduced cost? With UltraStar DC ME200 memory extension drive from Western Digital, there is. The UltraStar DC ME200 memory extension drive reduces the complexity and cost of scaling your in-memory infrastructure, offering you the flexibility to grow your business. UltraStar memory works in conjunction with physical DRAM to create large virtualized pools of memory for use by in-memory applications. Available in 1, 2, and 4 terabytes of system memory per drive and up to 24 terabytes of system memory in a 1U server, now your company has an alternative solution to scale memory-hungry applications without the pains of OpEx and CapEx overruns. Western Digital, we're just getting started.
That went okay, technology-wise. Okay, so just to wrap it up, we launched this new segment of accelerator and specifically the UltraStar memory extension drive back in November in HPC, a geeky product for a geeky audience. That went berserk. Think about all these guys that are doing all this heavy lifting, in-memory computing. Suddenly, it's like Christmas. They can add and extend memory for a fraction of the cost, and with utilizing the PCIe available slots, they can now use 1, 2, and 4 terabyte extension drives. So that gets you on a 1U, you are able to get to 24 terabyte of memory. Okay, so we did that in November. There is a huge interest in that product line. They are dropping replacement for x86 servers. There is a part of this solution is software, but it is transparent once you install it. And we have a very attractive landing page for you to go and see a lot of white papers and where that fit. Just to summarize what attractive applications and which customers or which application owners need to be focused on that. So everything that is executed in memory, like Memcache, everything that is multi-tenants, and which the CPU keep waiting for. We have some really cool stuff in the software that allows us to unblock those scenarios. And basically, just to understand what you see here, if we're looking at the SAP HANA application, for example, by taking a DRAM capacity, you are able to extend it up to 8x of that capacity, 8x capacity, and you still reach 95% of DRAM performance. Okay? And there are some other numbers here for you to look at. We can continue to talk to that. So I'm sorry for taking so long. I will never show again a price slide to analysts. But I hope you had fun. I'm very happy that we had this session together. As part of the devices, whatever you want, we have for you. We have NVMe. We still ship SAS and SATA SSDs. We will continue to support our OEM with low capacity HDDs, and we will continue and innovate greatly to support higher and higher capacity points based on our Helium drives for the cloud, guys. And with that, I think I'm saying thank you. Thank you.
Right, so good morning everyone. Sorry, good afternoon. I think we've turned over to afternoon now. So up until 5:30 yesterday evening, I wasn't supposed to be here. My colleague Paul Haddo was presenting. Unfortunately, he's been taken ill, so I've stepped into the breach, or was volunteered, one or the other. So let's see how this goes. So I'm going to give you an overview around the Data Center Systems Group and around the systems themselves. So our expansive portfolio of data center systems covers the UltraStar platforms element. It covers our OpenFlex technology. It covers the ActiveScale and the IntelliFlash piece. Now, Esther is going to cover the platforms and the OpenFlex side of things shortly. I'm going to give you a brief insight into the ActiveScale object storage platform. Okay, so our cloud scale object storage platform, and the IntelliFlash all flash platforms, all NVMe based platforms. Systems, I should say. So, all of our systems kind of adhere to this practice of silicons to systems. So we're taking, as we've seen on the other slide, we're taking the NAND wafers, we're building them into our devices, we're taking those devices and we're integrating them into our platforms, and then we're layering on our secret sauce to deliver our turnkey systems. Okay, one of those is our IntelliFlash all NVMe array, okay, as well as our ActiveScale object store. So if we touch on ActiveScale, this is our cloud scale object storage system. But this system is all about data durability. Okay, we're starting at kind of 500 terabyte entry point to the platform, and we're looking at kind of adding durability to data. It's not necessarily availability, but durability. So that data can be available after multiple failures. Now we can build in 19 nines worth of data durability into this platform. So that could be kind of at its extreme in effect. We can choose different levels of erasure coding, different levels of redundancy in there. We can spread that replicated between a couple of locations. We can do a 3-site geo replication to add that redundancy and to give us the capability to lose an entire site or lose devices across multiple sites, but still retrieve that data back from the system. Okay, so it's giving you that level of data durability at a high performance point. There are a couple of models within the ActiveScale platform. We've got the P100, which is kind of the entry point. Typically, this is looking at the lower capacity points with customers that don't need to scale up to kind of the maximum sort of 63 petabytes in size, don't necessarily have as much kind of throughput requirement from the platform. For customers that are more throughput sensitive, that need to scale further than the 23 petabyte kind of raw capacity point on the P100, we have the X100. Okay, so this has got additional compute. Okay, additional performance, additional network interfaces on the kind of front end of it from the ingest perspective, and then on the back end we've got a higher performance layer within the platform as well. Now, You'll see a common theme across ActiveScale and IntelliFlash, and this is around the metadata acceleration. Okay, so within the ActiveScale platform, we're segregating the metadata, the data about the data, moving it onto high-performance SSDs within the platform. Okay, so the small lookups are done from a more performant tier, whereas we're storing the physical data segregated on the underlying disk drives within the ActiveScale platform. Okay. The management side of things, again, a common theme across our systems portfolio. We have cloud-based management as well as on-array management. So we're receiving telemetry from the arrays, giving us the ability to create reports, to look at trending, to give capacity projections, so looking a year into the future to see when we need to expand. All of our systems are scalable, so we can start off at a kind of small 500 terabyte footprint and scale that with modular increments of disk drives, etc., into the system on the fly to grow that capacity point to allow customers to grow modularly as we scale. So a couple of examples of customers or kind of data sets that have worked really well. So we've got a bioimaging research centre, UK based, that have actually got a 60 petabyte 3-site geo configuration. So they've gone for the kind of the ultimate in terms of data durability. And they're also an IntelliFlash customer as well. So they're a dual site kind of customer for us. So they're putting their more performant workloads, their VMware based data on the IntelliFlash platform. They're storing their more kind of not cold data, but more static data, more unstructured data is being held within the ActiveScale platform and within there as well. Engineering, automotive manufacturer, again, customer that is using or is taking the telemetry from their cars, okay, and storing it within the ActiveScale platform as objects, allowing them to kind of analyze kind of data that's coming in. But again, they need to be able to go back to that data after a period of time. They need to be able to run different analysis on that data, so they need it stored securely and in a durable fashion, hence why they've gone from the ActiveScale platform. And then to kind of move it to a different area, we've got kind of a financial data set there that again is held within the platform, but in a Hadoop system there with HDFS. So moving on to the IntelliFlash portfolio. So this covers our all-flash arrays. Okay, we've got the T-Series platform. This is the entry point into the system. Now, within the T-Series range of products, we've got our hybrid range, so the T4100, the T4200. So the combination of flash media and spinning disk. Okay, for those kind of lower performance points where we're caching the active data set, as it were, and accelerating that for the customers. We then move into the all-flash arrays within the T-Series platform. So this in the kind of capacity points, maybe 7 terabytes, 15 terabytes, 30 terabytes on the initial footprint, okay, within the T-Series platform. We're delivering a decent amount of IOPS from the platform, and I can give you workload characteristics later on. But the key thing around this platform is we're delivering at a consistent sub-millisecond latency within the all-flash range. For those higher capacity points, where we need to use dense flash, we have our HD series. Now this, again, has the same kind of controller horsepower as the T-Series controllers, but we're incrementing up the size of the flash modules. So we're using 4 terabyte dual-ported flash modules within the 2040-100, for example, 8 terabytes in the 2080-200, and then in the future we'll have the 16 terabyte modules to expand that initial capacity footprint out up to kind of 240 terabytes of true usable capacity in a 2U footprint. Now these platforms are extremely power efficient. I'm working on or deployed several projects where we've done extremely good TCO analysis, where we're taking multiple racks of legacy systems that are consuming multiple kilowatts of power down to a single 2U footprint that's delivering utilizing 495 watts of power. So they're very space efficient, they're very power efficient, they're very performant, okay, and very cost effective at scale by using the HD platform. And right at the top end of the tree, we have our all NVMe array. Now this is delivering consistent sub-millisecond latency, so 0.2 millisecond latency. It's all NVMe through the backplane, so we've basically removed the SAS backplane from within, between the controllers and the underlying flash modules. Okay, so we've taken out a layer of latency, allowing us to deliver that lower latency point. Okay. But regardless of whether you're starting with the T-Series hybrid product, all the way through to the NVMe platform at the top end, Okay, it's the same operating system, it's the same feature set, it's the same user experience across the platform. So if you can manage an entry-level hybrid, you can manage the top-end NVMe.
Will you be introducing NVMe over Fabric access to the N series?
Okay, so the ultimate end game for the NVMe-based platform is to have that application through to underlying NVMe-based flash as all being NVMe. Okay, so NVMe over Fabrics is the next logical step on the front end. But as it stands at the moment, okay, it's the traditional block protocols over Fibre Channel, iSCSI, file-based protocols, so SMB3 or NFS from the platform at the moment.
But I will talk about the current NVMe over Fabric hardware platform in a little bit.
Yeah. So the NVMe-based arrays themselves, the 5200 and the 5800. Okay, capacity points ranging from 20 terabytes up to 180 terabytes of raw flash NVMe-based flash capacity. Extreme performance. Okay, well, the market space we're kind of finding that these products are fitting at the moment is for those customers that have got point high performance or low latency workloads. So extreme databases, for example, where they need that really responsive, low latency storage platform. It could be the difference on a trading platform from them winning a trade or not, as it were. Okay, we're delivering that performance, that capacity, at good value as well. Okay, so in competitive scenarios against other NVMe-based players, we've been significantly cheaper, more cost-effective with those for those customers as well. And then in terms of scalability, scale the back end out. We can multiple different connectivity on the front end, and again, as we've already talked about, which is a perfectly reasonable question, was the kind of connectivity moving forward to moving to kind of an NVMe over Fabrics from the application all the way through the stack to give us that extreme low latency from application to flash, to drive the flash for what it was meant to do, in effect, extreme low latency. So in terms of the actual software that's within the platform, let's just expand this out, or functionality I should say. So again, I touched on metadata acceleration earlier within the ActiveScale platform. The IntelliFlash platform has this as well. So we're segregating the data about the data. We're also we're moving that to our performance tier within the platform. Okay, so we're making sure that that's served. Those small kind of randomized read and touch updates to dedupe tables, etc., are being served from the appropriate tier within the platform. So end-to-end data integrity, so checksums of the data coming in. Encryption, we're using self-encrypting drives as standard. Okay, so we don't suffer a performance penalty by layering in software-based encryption as some other vendors do. We don't have to induce CPU cycles, etc. It's done by the devices themselves within the system. Okay. Snapshots and clones, standard. Inline deduplication compression, as standard. Okay, our controllers are spec'd so that we can run continual inline deduplication and compression. We turn it off for specific. Thank you. Asynchronous replication, and we can replicate between dissimilar technologies. So we could have an NVMe-based system on one side. We could replicate to a more cost-effective hybrid platform on the other. Okay, so we can create bespoke configurations for customers rather than having to be all flash on both sites, for example. We had the capability to scale in different ways as well. So we could start with a high-density flash platform. We could add in a hybrid flash platform, flash shelf to the system, so we could actually create two pools of differing performance capabilities behind the same set of controllers. So we have flexibility for our customers within the systems as well. Multi-protocol data access we've covered, multi-parity RAID, so double parity configurations, triple parity configurations if we want to, so we can build in additional redundancy within the platform. Some of the other key elements, the cloud-based management, the IntelliCare piece that sits over the top that gives our proactive support layer. It also gives us the ability to do trending, capacity utilization trends into the future. We can drill into performance, okay, as well as receiving the real-time analytics from the arrays to do it kind of instantaneous performance information. And other features such as thin provisioning, which you'd expect from an enterprise class storage array. Yep, I'm going. This is my last one. Okay, so a couple of cases around where we've utilised IntelliFlash successfully. So I mentioned the research centre that's using us on VMware workloads. So major vacation rental company, I know this one well because I ended up doing the installation for the piece that's over here. It's a global scale customer, multiple high density flash arrays deployed across 4 sites. So this is consolidating their data storage, so it's multiple platforms coming into a consolidated high density flash arrays. It gave massive improvements in terms of performance and response times within the platform. An exceptional
Did you do any data
TCO.
elimination in that as well? Did you do any data elimination, or was it just literally replicate what was there and shove it into the new one?
They did some consolidation of their data sets. We helped with our kind of deduplication and compression to kind of reduce the footprint down. But again, specific moving data sets out and in, that was kind of down to them what they were doing.
So you don't know whether they actually did any proper data games or data.
I don't know. I didn't get that kind of depth of it. Leading Formula One team. So extreme environments of humidity, dust, whatever you like, vibration at the track side. Okay, this is used for real-time data analytics, so it's allowing the Formula One team to make those decisions a lot quicker. Okay, whether to choose a different tyre compound based on the telemetry that's coming back from the cars. Okay, whether to add a twist of a downforce on the front wing, or etc., etc. Okay, and then on the Major League Soccer side of things, this is a customer that started off on HD. They needed some more performance, as it were, because they had a particular data set that required lower latency, so they then moved to NVMe. Okay, and the NVMe platform has given them that capability. And that's me done.